Okay, guys, good morning. Again, sorry I'm not going to be able to hang out today. Standing up right now is actually pretty painful, but I'll do my best to think well and clear for you all. Okay, today we're going to start our uh, arduous adventure into trigonometry. Okay, we're going to start with baby steps, so relax. Everything's going to be explained to you along the way. All right, we're going to start first with the tangent ratio. Now, I don't want you to get too caught up about these ratios. All right, understanding them is very difficult. Using them is not as difficult. Okay, so understanding will come later when you're more comfortable with it. I know that sounds bad to some people. Like for me, I had such a hard time with math when I was your age because no one ever explained to me like what the big picture was. But the truth of the matter is, was, if someone did try to explain the big picture to me, I wouldn't have gotten it. My brain wasn't big enough to be able to really comprehend how it all fit together. It wasn't only until college that I really started to understand, what these ratios really are and their connectivity to the rest of the mathematical world. All right. So I know that it's kind of lost upon a lot of us right now, but just trust me, just work it out, do the exercises, and with each little exercise, another grain of understanding will fill your cup, and years from now, it'll start coming together if you do decide to follow the path of math and science, which of course I hope that everyone does. The world's a better place because of it. So let's start out. So what are the trig ratios? We're just going to really look at one of them today, but there's this silly mnemonic which will bring you everywhere. So let's just go ahead and title this. In our textbook, it's 7.5, right? But in our curriculum, let me just double check. Our curriculum, I'm pretty sure it's I'm pretty sure it's 2.6. Yeah, 2.6. We skipped 2.4. So 2.6 intro to tangent. Okay. So there are these things called trig ratios. We're going to learn one of them first. It's called the tangent ratio. So there's this mnemonic. It goes so, ka, toa. One of those things you're going to have to just memorize. Okay. Put that on. Alexa, volume 1. Sorry, guys. Okay. Actually, Alexa, stop. Sorry, a little too loud. Okay, so I know it sounds silly, so ka toa, but it'll help you out. I mean, we're not going to talk about sine or cosine today, okay? But just because they're here, the first function is sine, okay? It's the ratio of the opposite over the hypotenuse. This one's cosine. It's the ratio of the adjacent over the hypotenuse, and this is tangent, the one we're going to learn today, and that's the ratio of the opposite to the adjacent. So what am I talking about, these ratios? Well, we use trigonometry to kind of link angles and sides together, and they're pretty old. Let me show you what I mean. So let's go ahead and sketch a right triangle. Okay. All right, I'm going to go ahead and label this triangle 3, 4, 5. It's a common right triangle. All right, I'm going to go ahead and label this A, B, and C in no particular order. Okay. So what we do is we say that tangent, might as well just jump right into an example. Okay. Tangent, or usually just write tan, of an angle is equal to a ratio. Okay, so if I'm looking from A, this is what determines my perspective, from which I look from, right? That's what a perspective is, from where you look from. So we're looking from A. Now, tangent is the ratio of the opposite to the adjacent. So I might want to write that off to the side here. Tangent is the ratio of an opposite and adjacent side length. We're talking about length here. Okay. Okay, so maybe we should label those opposite and adjacent sides. So in relation to angle A, which is, from where I am looking, from angle A, what's the opposite side? Well, to find the opposite side of angle A, you have to find the side which doesn't involve angle A as an endpoint. So you look opposite, there's my side BC, right? So this is my opposite side. Okay, we've been doing this in relation to angle A. What's my adjacent side? Is it 5 or is it 4? Well, it can't be 5, right? Because 5 has to be the hypotenuse, which we talk about when we talk about sine and cosine, not when we talk about tangent. And then this must be the adjacent side, right? The side that involves angle A, right? Angle A is BA and AC. Those are the sides of angle A. So BA is one of those sides. All right, so again, this is the ratio of the opposite to the adjacent side, TOA. TOA. So tangent of some angle is equal to the opposite to the adjacent side, right? So if I were to throw in some numbers here, I actually have to figure out what that angle is. So just give me a second. Don't worry about what I'm going to do here. I'm just going to do the inverse operation for tangent A real quick. Maybe I'll pause. Can I pause? Wonder if I can. I don't think I can. I don't think I can pause. Oh, yeah, here. Okay, so we're back. I just looked up the angle measures real quick. So it turns out that this angle here in a 3, 4, 5 right triangle is 37 degrees. Sometimes it's a little easier for us to understand things if there's numbers involved. So it turns out that if I throw in here the number 37 with the tangent function, again, don't try too hard to understand, just try to do it. Okay, tangent of 37 turns out that that's equal to the ratio of the opposite to the adjacent side. Okay, so this is the relationship that we're trying to show here. Okay, so it turns out that this one over here is 53 degrees. Okay, so I have the freedom to choose. I don't have to just have tangent of A. I could choose to look from tangent of B. I'm sorry, tangent of C if I choose to. So what would tangent of C be? Of course, tangent of C is still the opposite to the adjacent. But look, if I'm looking from angle C now, I'll go ahead and I'll do this. I'll do this, and I'll do it in red. Okay, this is the angle from which I'm looking from now, right? So what was opposite and adjacent have now swapped. Because what's opposite angle C? 4, right? So now this is the opposite side. And what's adjacent to angle C? Well, it can't be this because that's still always the hypotenuse. Hypotenuse doesn't change. But this is now the adjacent side. Okay, why? Because we're looking from a different angle. So go ahead and pause the video and rewind it if you want to catch that again. So what is tangent of C? Well, C, we don't even have to know what C is, okay? But in this case, I do. It's 53 degrees. That's equal to the ratio of the opposite side, which is 4, to the adjacent side, which is 3. And you can throw these things into your calculator and actually get these answers if you'd like. So that's really all it is, guys. It's just the ratios of the side lengths. So be able to identify what's adjacent and opposite based upon what the angle is, right? So tangent of some angle, these are angles, and these, right? These are sides. Okay, so it's a ratio of sides and you input an angle. So those are the big ideas for the tangent ratio. And tomorrow we'll do sine and cosine. Let's go ahead and do some examples with these and see how we feel about it. All right, I think let's just jump right to this. Okay, I'm not gonna hound you with that. You'll understand it through examples, I think. So they want us to find tangent of S. So tangent of S is equal to something. I need to figure out what that is. What's S? S is this angle, right? Okay. So in relation to angle S, what is the opposite and adjacent side? Remember, SOHCAHTOA. TOA. So I'd recommend writing that a million times to the point that it's nauseating, just so you don't mess that up. So tangent is the ratio of opposite to adjacent. It's just a way to remember. All right, so what's opposite angle S? Is it 82, is it 80, or is it 18? What's opposite angle S? Well, it's 80, right? That's the side that doesn't involve S at all. Which is the adjacent side, 18 or 82? Well, it's not 82 because 82 has to be the hypotenuse, right? Because it's opposite the 90-degree angle. So this must be the adjacent side. So tangent of S is the ratio of, remember, it's opposite over adjacent, right? What's opposite? Oh, it's 80. What's adjacent? Oh, it's 18. So that's my answer. All I have to do now is make it a little bit prettier. That's what? That's 40 and 9. And I think that's as pretty as it gets. Okay, so they want it as a decimal too. All right, I guess they want us to be fancy. It's no big deal. Just take it, throw it in your calculator. 40 divided by 9. That's going to be, we want 4 decimal places? Geez, 4.444, and that rounds down, so 44. Just like that. Okay, now let's do the next one, tangent of R. So tangent of R. Remember, it's still opposite over adjacent, right? All right, but this is angle R. So now I'm looking from here. All right, so now what's opposite to angle R? Is it 80, 18, 82? What's opposite angle R? It's this one, right? What's adjacent to angle R? Is it 82 or is it 80? It's 80. And of course, the hypotenuse is always the hypotenuse. Okay, so looking from angle R, it's the ratio of the opposite to the adjacent. So opposite is 18, adjacent is 80, and we already simplified this to 9 over 40. And let's see what that is inside of a calculator. Focus here, bud. .225. Okay. So there you go. Another way you can use trig, tangent function, is to actually solve for side lengths. Because right now this isn't a number, this is a relationship. But if I plug in an input here, it'll actually give me a number. Like I'll just do a silly example. I can do like tangent of 0.5 if I wanted to, and I get some sort of number out, right? I can do tangent of 20 degrees, and it'll give me some ratio, like some decimal, which is a ratio of two numbers. So they want us to find the value of x. Okay, this is x. They've given me 32 degrees. I'm going to go ahead and use 32 degrees, even though I could probably figure out what this is too. Really easy using triangle sum theorem, right? All the angles at that 180. Let's just use 32. So in relation to 32, what is 11? Is it opposite, adjacent, or is it the hypotenuse? In relation to 32, it's the opposite side. Okay. In relation to 32, what's x? Is it the adjacent or the hypotenuse? Well, this is the adjacent. Okay. So I don't have the hypotenuse. I have no choice here other than to use trigonometry to solve. I can't use Pythagorean theorem, right? I wonder what happened to my like little webcam thing. Anyway, I am recording, right? Yeah, I hope so. All right, great. All right, so tangent of 32 degrees. Okay, tangent. Remember, SOHCAHTOA, opposite over adjacent. What is opposite over adjacent? Well, opposite is 11, and the adjacent is x. Okay, so now I have tangent of 32 degrees is equal to 11 over x. Well, this is algebra. The name of the game is get x by itself. So to do that, it's a problem since x is in the denominator. I'll multiply. There's a lot of ways you can do it. I'm just going to probably do it the simplest way. Multiply both sides by x first. That'll get rid of them in the denominator, right? So let's rewrite that. Now I have x times tangent of 32 degrees equals 11. Now to get x by itself, I have to get rid of that tangent 32, right? So I'm going to go ahead and divide both sides by 32, tangent 32, because that's the number, right? Tangent is not a word, it's a function, and it's kind of attached. So never separate the angle from the function. Never separate the angle from the function. So these will cancel, right? And x is equal to whatever this is in a calculator. 11 divided by tangent of 32. Okay, so let's check that out. If you're not getting the same answers that I am, you want to make sure that your calculator is in degrees. So if you want to make sure your calculator is in degrees, you go to mode and make sure that this is highlighted and not that, okay? And then you get out, you do second, and you quit. All right, so we'll enter that 17.6037. 17.6037. Okay. So that's, I mean, it's an ugly answer, right? It's really long, but that'd be the length of x. So we did it right. Okay. So sometimes I'd like to throw in a little bit of, context to make it seem, I don't know, more cool or something. Whatever. Our job is to figure out h. Okay. So they had this idealized picture. It's still just a right triangle. Right triangles are everywhere. Hopefully you can appreciate that and see them. But yeah, here it is. Sorry, I heard something upstairs. Anyway, all right, so let's go ahead and solve for h. I'm looking from this 70 degrees. So that's kind of like, I don't know if you can see that really. That's no better. I'm looking from that 70 degrees. Okay, so I want to first label my sides opposite, adjacent, hypotenuse. Remember, you should always have this ready. SOHCAHTOA, right? Tangent is opposite over adjacent. So that's what we are drilling today. So what is opposite 70? Is it h or is it 40? It's h. This is the opposite side. Okay. What's the adjacent side? Is it this unknown or is it this 40? The adjacent side is here. All right, this is of course the hypotenuse, but I don't really care about the hypotenuse here because they're not asking me about it, and I have a function that doesn't even involve the hypotenuse, so I'm going to go ahead and use that one. So let's set it up. All right, so tangent of my angle, 70 degrees, is equal to a ratio. Hold on a second. Okay, sorry about that, guys. I thought I heard something upstairs. Kind of freaked me out. I am home alone. All right, anyway. Where were we? So tangent of 70. So remember, tangent's the ratio of the opposite to the adjacent. So what is opposite? Well, we already decided that, right? Opposite is h. What's the adjacent side? That's 40. So let's solve for h, get h by itself. First thing I do is multiply both sides by what I want to go away from the denominator, so that'd be 40. That will cancel, right? So now h is equal to this product. I know it looks scary, but just let your calculator do the work. Okay, 40 times the tangent of 70. That's going to be something. 40 times. I recommend you do this with me too. Bust out your calculators. Tangent of 70. Whew, 109. Kind of makes sense in context of the problem. 109.8991. Oh, wait, the one's the nearest inch. So 89 is definitely going to round up. Well, it's going to end up being 0.9 anyway, so it's going to round up to 110. So we're going to say 110 inches. Okay, it does make sense in this context. All right, that's another example for you. And I think that may be the last example for the day. All right, we will, of course, hit sine and cosine tomorrow. So this is what we learned. All right, a trigonometric ratio, like tangent, all right, like sine and cosine, which we'll talk about tomorrow, is a ratio of the lengths of two sides in a right triangle. Okay, like BC to AC. We will use trig ratios to find the measure of a side or an acute angle. Okay, we can use trig ratios later on, inverse trig ratios to find angles. First, we'll worry about sides. For the ratio of lengths of the legs in a right triangle is constant for a given angle measure. This ratio is called the tangent of the angle. Okay, opposite over adjacent. Remember, the legs are here. This is, of course, the hypotenuse. Okay, so that's the tangent ratio, guys. Throw this into your notes. If you'd like, the IXL is a sine, but you'll also have sine and cosine in there. So I wouldn't recommend starting that yet. This should be enough to keep us going for the day. We'll pick up here tomorrow with sine and cosine. Again, sorry for having to do this to you. I wish I could have stayed in class, but I have to go lay down immediately. I'll see you guys. Okay, how do I stop this thing here? There we go.